So you don't have to copy this down, but I want you to make sure that you understand the difference between included and non-included. This first example, we have triangle ETG, and we want to know what the included side of E and angles E and angle T is. ET, angle, side included, ET. Easy enough, right? Okay. Because you were thinking of the other angle. Okay. So name the included angle for sides TE, TG, and TE. What's the included angle? T. T's in both. Okay. Last example in this one. Included side for angles T and G. TG. Okay. The ones that are right next to them. So they have to be all in a row to be considered included. Okay. No gaps, no jumps, no hops. Okay. Non-included side. E and T would have what non-included side? I heard someone say EG. They're correct. Is there another one? TG. You can't say ET because that's included. The other two sides are non-included sides. Okay, we had to jump past a side to get to the side. Had to hop over something. Okay? Non-included side of angles G and E. G and E, non-included, ET or TG. You're correct. Okay? So here's your angle side angle theorem. Angle side angle says that if two corresponding angles and the included side of two triangles are congruent, then the triangles are congruent. Two corresponding angles and the included side of two triangles are congruent, then the triangles are congruent. Notice the included side. They are all in a row. No gaps, no jumps, no hops, no skips. So how would we name these triangles? What's the name of the first triangle? PQR. So if we start at P and go to Q and then to R, then we have to say S to T to U. Does everyone see why? P and S are congruent angles. Q and T are congruent angles. R and U are congruent angles. Okay. Next example. Next theorem. Angle, angle, side. One way to remember the previous one, angle, side, angle, is like NASA without the N. The way to remember angle, angle, side is everyone wants A's. AAS. Angle, angle, side says that if the two corresponding angles and their non-included side of two triangles are congruent, then those triangles are congruent. Two corresponding angles and the non-included side of one triangle are congruent to two corresponding angles on the non-included side of the other triangle. Those triangles have to be congruent. So notice here how we skipped a side. They're all clustered together down here. We went from angle to side. Non-included side. Okay? So which theorem would make these two triangles congruent? I see an angle and I see a side. Can we get another angle or another side? Do they share a side or do they have vertical angles? Vertical angles. So now, is this angle, angle, side or angle, side, angle? Why is it angle, angle, side? Two angles and a non-included side. We had to skip over this side to get to the other one. Okay? Two angles and the non-included side. How about this next one? Angle, side, angle. Why is it angle, side, angle? Yep, two angles. They share a side. Okay? And don't think of this as being a side that's included in both triangles. Think of it as a side that is included between the two angles. It's between the angles. Okay? Two sides and the included angle. Okay? So angle, side, angle. Okay? So here's our proof. Draw the figure. Jot your givens down in your first statements, and your reason is given. This one is just on a separate sheet of paper. Don't have room in our foldable for it. Draw the figure, label it. So draw the figure, label it, write your givens down. We're trying to prove that triangle RLD is congruent to triangle CDL. RLD, CDL. Then put the marks on the triangles that match the givens. Sure you can. Angle 4 is congruent to angle 2. Make the arcs. Show that 4 is congruent to 2. Okay. What does this symbol mean? Parallel. So segment RL is parallel to DC. How do I show that in my drawing? arrow. So they're parallel. What does that mean? Going on and on and on forever, never going to cross, right? Okay. So can we get any other angles or any other sides congruent? 1 and 3. Why, Piper? Awesome. Angles 1 and angle 3 are congruent because they're alternate interior angles. And if you want to abbreviate that by AIA, that's perfectly fine. Two parallel lines cut by a transversal. They are on the inside of those parallel lines. They're on opposite sides of the transversal. They're alternate interior angles from last chapter. So we have two pairs of angles congruent. What else do we need? A side. How can we get a side congruent? LD is equal to itself. It's in both triangles, isn't it? What's our reason? Reflexive. When you write something's equal to itself, it's like a reflection in the mirror. So we say reflexive. Are the triangles congruent? Why? Why is it angle side angle and not angle angle side? You're right. Angle side angle congruent to angle side angle. It's the included side. NASA without the N. That's it. Short and sweet, right? Okay, that's how we like the proofs. All right. Assignment.